We are going to find the perimeter of this trapezoid ABCD. In order to solve this question, we need to know two informations. So let's start with them first. The first one, opposite sides of a rectangle are parallel and have the same length. So you see a rectangle in the figure. The opposite sides, so for example this side and this side, are parallel to each other. So these two sides are parallel, and also these two sides are parallel because they are opposite to each other. And they have the same length. For example, if the length of this side, is A units, then the length of this side is also A units. And if the length of this side is B units, the opposite side, this is going to be also B units in a rectangle. The second information that we need to know is Pythagoras theorem. So in a right triangle, the side opposite to 90 degrees, it is called the hypotenuse. And the square of hypotenuse, so which is C in this example, in this triangle, C squared is the sum of the squares of the other two legs. So C squared is equal to A squared plus B squared in a right triangle. This is called Pythagoras theorem. Alright, so these two informations are enough for us to solve this question. Let's solve the question. The perimeter of this trapezoid. So you see in the figure we have this length AD, and the trapezoids, this is the property of trapezoids. AB and CD are parallel, and actually you can understand that looking at these two 90 degrees. Okay, they're add up to 180 degrees. That means AB and CD are parallel. So if I draw another line from C to AB, but that line is going to be parallel to AD. So let me draw this line. So let's say that this line is parallel to AD. So these two lines are parallel. So we get a rectangle here. You see, the opposite sides are parallel. This is a rectangle. These are 90 degrees, so this is a rectangle. And the opposite sides have the same length. So you see, this is going to be 15. The length of this side is going to be 15. And the length of this side, it must be 6 because they're opposite. As you see, CD and this side are opposite, so it is going to be 6. So for the perimeter, actually we need the length of AB, but we got some part of AB, but we need to find the length of this part. So this is going to be 90 degrees because it's a rectangle, and this is 90. 180 minus 90, we're going to get 90 here. So we get a right triangle. So in a right triangle, the square of the hypotenuse, which is 17 squared here, 17 squared, is equal to, let's say the length of this side is x. So it's going to be x squared plus 15 squared. So 17 squared is equal to 289. 289. You can try that. You are going to multiply 17 by 17. You will get 289 is equal to x squared plus 15 squared. What is 15 squared? 15 times 15. You can multiply 15 by 15 and you will get 225. So 289 is equal to x squared plus 225. We can take this 225 to the left. We will get 289 minus 225 is equal to x squared. So this is going to be 64 is equal to x squared. So we got x is equal to 8. Here, if x is equal to 8, then AB is equal to 14, right? X is equal to 8. So the AB is going to be equal to 14. Alright, so the perimeter is going to be the sum of the length of all sides. So the perimeter is going to be 14 plus 15 plus 6 plus 17. So we got 29 plus 6, 35. So it's going to be 52. So 52 is our answer. The perimeter of this trapezoid is 52. Alright, so actually we could do something else here. We can solve this question after this. We could do this. We can take 15 squared to the left, so we'll get 17 squared minus 15 squared is equal to x squared. So this is the difference of squares. We can use this property. A squared minus b squared is equal to a plus b times a minus b. This is a property. So here 17 squared minus 15 squared is going to be equal to 17 plus 15 times 17 minus 15 is equal to x squared. So 17 plus 15 is equal to 32. 17 minus 15 is equal to 2 is equal to x squared. So 64 is equal to x squared. And then we get x is equal to 8. So if x is equal to 8, then 8 plus 6, AB is equal to 14. And then you can get the perimeter. So I want to talk about the Pythagorean triples here. You see, we have 8, 15 and 17 right triangle. This is a Pythagorean triple. And actually, if you know the most common Pythagorean triples, it's going to help you save time solving these questions. What are the most common Pythagorean triples? 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. These are the most common Pythagorean triples. So that means actually if you see that the hypotenuse is 17 and one of the legs is 15, then you can directly write that the other leg is going to be 8. Or if you see that the length of the legs are 7 and 24, then without calculation you can write the hypotenuse is 25. Actually, you can try. You will see that here 25 squared is equal to 7 squared plus 24 squared. You can calculate, you will see that. Another most common Pythagorean triple, 5, 12, 13. If you know only 2 of them, then the third you can just write directly. Okay, 3, 4, 5. These are the most common Pythagorean triples. And be careful, the side opposite to 90 must be the longest. So the side opposite to 90, the hypotenuse must be 5, 13, 25, 17. If you know one of the legs, and one of the legs, let's say 4, then the third one must be 3. You can actually get more common Pythagorean triples if you know 4 of them. For example, you can multiply all these by 2. 3 times 2, 6. 4 times 2, 8. And 5 times 2, 10. This is another Pythagorean triple. You can multiply all these numbers by the same number. For example, multiply by 3. 3 times 3 is 9. 4 times 3 is 12. And 5 times 3 is 15. Or you can multiply all the numbers by 4. For example, 3 times 4, 12. 4 times 4, 16. And 5 times 4, 20. This is also a Pythagorean triple. For example, here you can multiply all the numbers by 2, let's say 10, 24, 26. This is also another Pythagorean triple. So you can multiply all these numbers by the same number. Let's multiply by 2. 14, 48, and 50. This is another Pythagorean triple. So I think you get the idea. So in this kind of questions, if you know the Pythagorean triples well, then you can solve these questions easily. Okay, so it is your turn. Now you can try to solve this example, and you can see the correct answer in the description below.